Let us do a beautiful sum. It is a very interesting one and something which you can do on your own. Let's see the sum. It says that quadrilateral ABCD is a parallelogram. So we have this quadrilateral as a parallelogram. E is a point on side BC. Ray DE is intersecting ray AB at point T. That means they intersect at a point T outside the parallelogram. We need to prove that DE into BE is equal to CE into TE. Now understand this. Now this is very important. I've already said whenever we want two products to be equal, two products will be equal when two ratios are equal. So remember, two products will be equal when two ratios are equal. And two ratios will be equal when two triangles are similar. Right? So in order to get this, now there are triangles here. How do we identify which two triangles we need to get? It's very simple. Right? When you look at the names here, DE, look at DE. So identify, we have DE, that's this segment. BE, when you look, that is this segment. CE is this particular segment which you see here, and TE is this segment. So when you look at this, tell me these segments, these two segments belong to one triangle, that is triangle BTE, and these two belong to another triangle, that is DCE. So we have identified the two triangles here. Very simple, right? So if we prove these two triangles to be similar, we ultimately end up getting the two ratios equal and we get the product equal. Isn't that easy? Very simple, right? Now, when you look at these two triangles, observe, do we have one pair of angle which is congruent directly, which you can see and just tell me, yes, very simple. That is vertically opposite angles, isn't it? Yes. We need to get one more pair. If we get that one more pair of angle congruent, we are saying, yes, the triangles are similar, and hence we end up getting the ratios equal and the product equal, right? Simple. How do we get that? Now, for that, we have this as a parallelogram, right? In this parallelogram, we know that opposite sides are parallel. So we can take AB parallel to DC, isn't it? So these two lines are parallel, right? I can write this AB as AT. Can we? Yes. Why? Because we know that A dash, B dash, T, because they are collinear. So observe here, yes, right? So instead of AB, I'm going to write it as AT, and that is parallel to CD. We know the reason, it is A dash, B dash, T. Now observe very carefully. For these two lines, we have a transversal. We can consider a transversal DT. Now, observe, if for these two lines, if I take this as a transversal, we get a pair of alternate angles. What you're saying is very correct, right? You know what is that pair of alternate angle here? This is one angle is here, that is angle ATE, and the other one is CDE. We get these two angles to be congruent, and we know the reason, it is alternate angles theorem. So we write that angle ATD congruent to that angle CDT, and the reason is alternate angles theorem. But remember, my dear child, we need to consider this triangle. In this triangle, the name of this angle won't be ATE. This would be written as BTE. So now we change the name of that angle and we write it as BTE. Why? What's the reason for that? A dash, B dash, T, right? And the other angle would be not CDT, it would be CDE in the name of that angle. Right, so that is what we write here. We write the name of that angle there as CDE, and the reason here is nothing but A dash, B dash, T, and T dash, E dash, T. We got this, and that's our result number 1. Now this is the pair of angle which we are searching for. Now can we prove both the triangles similar? Yes, we can. So let's do that. So now we consider both the triangles. Now when we are considering both the triangles, remember one thing. Write the name of the angles as per the correspondence of the vertices. Now when you're doing that, that's very important. Remember, we write in this triangle we know this T corresponds to D and E will correspond to E because that's a pair of vertically opposite angle. So when we write the name of the first triangle as BTE, that is blank, then the star, and then the vertically opposite angle. Here it would be starting from C, that is a blank, then the star and the vertically opposite angle. So if this triangle is BTE, then this has to be CDE, isn't it? That's what we have written there. So in this we know that these two angles are congruent. Why are they congruent? We know the reason. It is from 1. We have the pair of vertically opposite angles. So we write the angle BET is congruent to angle CED. And what is the reason for that? Vertically opposite angles. So now we write, yes, both the triangles are similar. Remember, write it as per the correspondence we have taken. So triangle BTE similar to triangle CDE, and they are similar to each other by a test of similarity. We wanted the triangle similar. We got it, right? Now once the triangles are similar, we can take the ratios, right? We want two ratios to be equal. So let's take the ratio which we want. If you look there, we want DE, we want BE. So we can see here BE is here. Yes, so we're going to take that BE upon its corresponding here is CE. So we write BE upon CE equal to. So we got BE, we got CE. What else do we want? We want DE and TE. So look here. Here we have TE, right? So pick up TE. Its corresponding here is DE. So we write there TE upon DE. And the reason for that is CSST, corresponding sides of similar triangles. Now just cross multiply. So what do we get? We get BE into DE is equal to CE into TE. And we got the proof. Was that easy? Beautiful sum, right? Very important sum.